what is vector database search, and then what is the reason that Pinecone exists?
Great. So to understand vector search, you have to understand that what AI has done recently is it created the ability to create a thumbprint of any piece of content.
Okay.
So let's take the example of...
Is a word a piece of content, or we mean like a sentence or a book or a picture?
Right. So literally so even a picture can technically be, I guess, represented as a series of characters.
Right.
But when I speak about content, I mean more like English. So a sentence is a piece of content, a paragraph, a whole page.
Got it. So this is like a language thing.
Any kind of content, you can run through this AI algorithm. OpenAI has an API called embeddings.
Yeah.
And once you run it through the embeddings algorithm, it spits out this thumbprint. And a thumbprint is this sequence of numbers. It's this list of numbers.
Yep.
And this list of numbers is unique and captures the intent and the kind of the look and feel of that content, which is an insane ability. And so just as an example, imagine you have you're at a company and you have all of your HR documents.
Yep.
Like the bajillions of pages that make absolutely no sense of your healthcare benefits, your side benefits, your whatever.
Front benefits,
back benefits. And and you run it through this embeddings piece, and every paragraph is now represented by this thumbprint. So now
the thumbprint is assigned by Pinecone?
By OpenAI.
Thank you.
By OpenAI, yeah. There's others as well out there, but most folks these days just use the OpenAI Ada embeddings. It's dirt cheap.
Yep.
And so now that you have the thumbprint for every paragraph, you can then go in and pose a question, like, for example, what are my healthcare benefits for emergency rooms?
Yep.
Okay. And then what happens is you create the embedding of the question, so the thumbprint of the question, and then you go and query and you compare the thumbprint of your question to the thumbprint of every paragraph, and that will surface the nearest neighbors, aka the thumbprints that are closest to each other, and that should contain the answers to your question. So this is what they mean by search, down here where they say search, right? So this is where it's able to retrieve content that has similar thumbprints to the context of your question.
Got it. Okay.
So what's Pinecone?
So here's Pinecone. Pinecone comes on the scene.
Yeah.
They're enabled by all this technology. They say they can do everything. What do they do?
They actually do. So once you have those thumbprints, you have to store them somewhere.
Yeah.
And your default could be, well, I'm just going to put them in a text file. But this is going to be a very, very long text file.
Yeah.
And then it's hard to search the text file. And then even more importantly, it's hard to run that computation. I think it's a cosine similarity is the technical term for each time that you compare two thumbprints to each other. Because imagine if you have a million thumbprints, which represents the millions of paragraphs. Somehow you have to store the million thumbprints, quickly surface them, and quickly compare your question thumbprint to all those millions of other ones.
Yeah.
And that's really challenging.
Yeah.
And so Pinecone comes along and says, hey, don't worry, we'll store all of your thumbprints, and we'll do so in a database, or they call them an index, that makes it super easy to then find the similar thumbprints. So once you've stored them, you just send us a call or an API call saying, hey, here's my new thumbprint, what's similar? And Pinecone responds with
boom,
this one, and that one.
These ones that have a higher value than X that you've asked for.
Exactly.
Great.
Exactly.
Okay, so what else, what does Pinecone give you? So how does it...
Yeah. So let's go into the docs for a second, and because it has examples of how this actually works. So I'm a Python guy currently, so that's what we're doing here. And so the thing I wanted to show is this thing called upsert vectors, right? So what this is showing is an example of, so imagine that vector 1 is paragraph 1 of your health benefits program, and then these numbers are that thumbprint representation.
And which OpenAI has given it.
Correct. So once you get...
Which includes, the reason it's given it is because it has read it.
Correct.
And summarized it or categorized it.
It has read it and created this thumbprint out of it.
Right.
Yes,
but
exactly.
But the thumbprint is the way it is because OpenAI has said, I've interpreted this data you've put in to be medical for older people that have diabetes. Like, it is doing
so
that.
We don't know exactly. So that's the crazy black box.
Black box.
We don't actually know. Like, so the OpenAI embeddings has 1,536 numbers or like digits or no numbers that it's used to represent any piece of content. We don't know like which number stands for what.
Got it.
But we know that if one thumbprint is close to another thumbprint, there's some close relationship there.
Great.
Yeah. So this is an example of like how you would load a thumbprint programmatically into the index. And then here's how it actually looks. So I guess we have to sign in or log in or something.
Yeah.
Is this okay?
Yeah, sure.
Google? Great. I'll just log in through you.
Do my...
Which one do you want?
That's fine.
All right, here we go. Bada bing, bada boom. Excellent. Look at that logo.
It's a Pinecone.
I know, it's great. I'm all for it. And so once you're in, you then
Sorry.
Oh,
Scoot this over a little bit.
Great, perfect.
Okay, there you go.
You then create your index, which is like creating a database. So this would be like sample, DB, and dimensions. So this is the number of numbers per thumbprint. So again, for OpenAI, it's 1536. And then they give you a few options for the kinds of pods, and then you create the index. And so once you've done this, now you're able to add to it using the code I showed you earlier, as well as query against it and get the results.
That's it.
That's literally all there is to it. And so the question is, like, what makes Pinecone unique?
Yeah.
Because there are definitely other ones out there that do the same sort of thing. Like,
sure, we looked at that. We said, okay,
yeah.
boom.
So like Chroma does the same thing. I've seen Weaviate as well and Milvus. They're all similar kind of data stores.
Yeah.
Maybe they do it a little bit differently, but the effect is the same. And it's unclear how Pinecone takes you in and keeps you as a customer.
Right.
Because it's pretty, like, the switching costs are not that high.
Yeah.
For me to go and like reload the data into a different database,
It's a low lift.
it's not a big lift, and frankly, it's like $1 or $2 of like the embeddings OpenAI. Like, it's not a big
And the
deal.
reason you would do that is because their customer service is bad, their servers go down, you're not getting the results you want. Like, what is... is that kind of just your standard?
That and price.
How accurate it is? I mean, is there a way for you to really measure how good Pinecone is versus others?
So that's the thing is,
Or
like,
you just kind of pick one and hope for the best.
well, so they're all typically based on open source algorithms.
Right.
So like this whole cosine similarity is open source. Like, most companies are not inventing anything new. They're just kind of building on top of
Layering
it.
on top of it.
And that's why, speaking to VCs these days, they don't know who to invest in, because everything's being built on the same open source infrastructure and concepts.
Yeah, there's no proprietary information.
Correct. So why would you choose Pinecone over Chroma, over Deep Lake? Some of them have just easier APIs. In other words, the thing I showed you earlier, let's go back to Pinecone, the Python kind of piece that lets you query against it. Like, Pinecone, as an example, does not store the content itself. So when you are sending something to Pinecone, you are giving it like the kind of ID of the paragraph,
Right.
and the thumbprint of the paragraph, but not the paragraph itself. So when I get the kind of the answer from Pinecone, it'll say, oh, like vector 2 is the closest one. Now I have to go back into my database and find the content associated with vector 2.
Right.
Whereas other things, like I think Chroma will actually store the original paragraph
Right.
with the thumbprint. So then kind of all in one swoop, I can get both the answer and the content behind the answer. So there's like small differences, but to me all that gets ironed out.
Yeah. Cool. Well, that's Pinecone.
Yeah. Cool. Thanks.
That's it. Close the box.
Here we go.
Digital box.